Now that we've introduced what intermolecular forces are, let's analyze the various types of intermolecular forces that we can find in various solutions. There are four types that we're going to investigate: ion dipole, dipole-dipole, hydrogen bonding, and London dispersion forces. So the first one that we'll look at is ion dipole. And these intermolecular forces really influence the physical properties such as boiling points, melting points of various liquids. So we need to make sure that we can recognize each of these. In an ion dipole, these intermolecular forces exist between an ion and the partial charge on the end of a polar molecule. In terms of these forces, they're going to increase with the charge of the ion, and they're also going to increase with the magnitude of the dipole, which again is based on the difference in electronegativity. So these will be discussed in more detail when we talk about solutions, and many of the times an ion dipole intermolecular force is responsible for solubility. So we'll cover this in a lot more detail in the next section. The second is called dipole-dipole. And a dipole-dipole intermolecular force exists when polar molecules are close together. And the dipole-dipole interaction increases with increasing polarity, or again, the difference in electronegativity. Okay, we'll discuss these in great detail in other sections. The third intermolecular force is called hydrogen bonding. And hydrogen bonding is more like a special type or more extreme dipole-dipole interaction. Okay? And in this case, a hydrogen must be directly bonded to a small atom of high electronegativity. And these atoms that we consider to have high electronegativity are going to be nitrogen, oxygen, or fluorine. Okay, so if we have a hydrogen directly bonded to either a nitrogen, oxygen, or fluorine, the dipole moment is so large that the force of attraction is pretty great. Okay, so we have to come up with a special case of this dipole-dipole interaction, which we call hydrogen bonding. And this phenomenon explains why ice will float on top of water. The last intermolecular force that we're going to look at are London dispersion forces. And sometimes these are also referred to as van der Waals interaction. And this is a very weak interaction formed by the uneven electron cloud in a molecule. Okay, and so if we have a molecule, there's electrons moving around them. And even if the bond itself is nonpolar, there are certain moments where the electrons can reside on one side of the molecule as opposed to the other. Okay, these are very weak because they only happen very briefly, but we do see some type of London dispersion forces. These forces will increase with polarizability, which is a fancy way to say the electron cloud is distorted. And they're also going to increase with size or molecular weight. And these London dispersion forces are more common in larger molecules. And it's worth saying that all molecules have some type of London dispersion forces, and it's the only type of intermolecular force in nonpolar molecules. So if we look and we kind of give a comparison, and if we compare the intermolecular forces, hydrogen bonds are the strongest intermolecular force, followed by an ion-dipole interaction, then dipole-dipole interaction, and lastly the London dispersion forces. And if we look at the magnitude in terms of kilojoules per mole, hydrogen bonds are roughly 15 to 25 kilojoules per mole, and ion dipole is roughly around 15 kilojoules per mole. The dipole-dipole are around 2 to 10 kilojoules per mole, and the London dispersion are around 1 to 5 kilojoules per mole. Okay, so remember, these effects are additive, right? So if there's hydrogen bonding occurring, you're also going to see London dispersion forces. But again, the hydrogen bonding is so much larger than those London dispersion forces that they typically tend to dominate over that. So analyzing intermolecular forces explain very many physical properties that we're going to talk about later in this section. And this is going to lay the foundation, and one of the first things that we have to do when we're looking at a particular molecule to explain some of the physical properties is that we can use these intermolecular forces to explain what's going on. So make sure that you're able to recognize each of these and do some example problems to help you identify which intermolecular forces are present between molecules.